Okay, I think we are live. So, yep, please let me know once in the chat if you guys. Okay, has ended. Okay, so if you guys can hear me, please let me know. Let me give a 5 star and submit. I think we are live. Okay, so, yep, please let me. I think you guys can hear me. So, 1 second. Let's go to the practice section. So, coding problems, and we'll go to the problems one by one. Okay. So, yes, we can. Great. So, I have seen some of you have actually given up when the contest was going on in the last few minutes. So, I'm assuming that the questions were really tough that you guys had given up so early, or you have solved it. Like, I'm not sure. So, yeah. How did it go? How did the contest go? Can you guys tell me? How did the contest go? Was it good? How would you rate the contest overall? Like, what were the problems too difficult, too easy, or medium? Like, it was good problems. And how did it go for you guys? First, let's do a bit of chit chat. Let others join in, and then we'll discuss. Like, start with the discussion. So, yeah, tell me, how did it go? Based among all previous contests, thanks, Sriram. And although I'm not the problem setter, to be just like to be clear out here, I'm not the problem setter, so kudos to the problem setters. And yes, look at you. Hello, good problems. Okay, code दे दो. देंगे code भी देंगे, कोई दिक्कत नहीं. Okay, so I think quite a few of you have joined. So let's start with our discussion. But I'm actually a bit surprised. The problem that was actually tagged as medium had received lesser number of submissions than the problem that was tagged as hard. Although it makes sense, because the harder problem actually you might many of you might actually know that you have to solve it using a segment tree and nothing else is there. But again, like, it was quite surprising. Like, this was also pretty easy, right? Okay. Talk is cheap. Show me the code. Yes, I'll show you the code. Don't worry. Okay, so let's start with our discussion. I think most of you have joined in, so let's start with our discussion. So we'll start with spatial palindrome substrings only, because this is tagged as a medium problem. So we'll start our discussion with this. I think everyone has read the problem statement. So you are given two strings, S1 and S2. Your task is to convert S1 into a palindrome such that S1 also contains S2 as a substring, right? So you have to convert S1 into S2, and S2, like S1 also contains S2 as a substring. And you have to do it in a minimum number of operations possible. And in each operation, you can replace any character of S1 with any other character. Like, I think it might be a bit confusing with word here, but again, if you look at the example, that would have made sense, right? So you can replace any character of S1 with any other character, right? So basically, you are given operations where you can replace characters, right? You can actually, by the way, this is the first problem. This is actually the first problem. This is a medium problem. The next one is a hard problem, but anyways, most of you actually solved that one, not this one. So this is actually the first problem. Okay, so if it is not possible to convert S1 into such a palindrome as contains the substring S2, then return a -1. So if you are not able to convert it into a palindrome as well as contain S2 within it, then you have to return -1. So for example, you are given this string ABAA and you are given the second string BB. So what you can do is ABAA. First, what you can do is you can convert this to B, A to B, and I think that makes it a palindrome, right? ABBA. If you convert the second A means this one, right? The third character. If you convert it to B, it becomes a palindrome. ABBA. It contains BB, and it also becomes a palindrome. And again, second example is ABBD, and you have to convert, and you have to add to it MR. Like, you have to convert some of the characters to MR such that MR is contained within it, and also it is a palindrome. So what you can do is, first you can replace AB to MR, so that will cost you 2 operations, and then you can replace BD to RM, right? So that will again cost you 2 operations. So A is replaced to M, B is replaced to R, this B is again replaced to R, this D is replaced to M. So MR RM is the final string, and this is palindrome as well as it contains MR. So this is the question. I think now many of you actually might have guessed what you have to do. But again, like one advantage that we have here with these problems is that we are given here the constraints. So that is always given to us, but also we are given the complexity as well. So n into m, although I don't think we'll actually solve in exact n into m, it will be max of n into m or n square. But again, like we'll see the code, right? So what we'll do is, the idea here being that we have a string with us, right? We have a string with us. We have to have the second string as a substring of this, and also convert it to a palindrome. And we can replace we can replace character by character, and each character replacement costs us one unit, right? Okay, what to do? First thing that we have to do is we have to make sure that s2 is there within s1, right? So for that reason, what we can do is we can actually do a brute force like solution where we try to insert s2 or replace s2 in every possible indices, right? So for example, let's understand this with an example: a, b, b, a, and b, b, right? So let's take this example here. So we have a, b, b, a, and b, b, right? What we can do is we can try placing bb or try replacing bb in all possible places. So let's say in the first index bb is replaced, so it will become bbba. What is the cost here? Cost involved with this, the cost involved with this is 1 unit, right? Only a has to be changed to b. Let's say b is to be inserted, bb is to be inserted in the second place. So okay, did we have abba? I think we had aba. Sorry, my bad. My bad. So I'll just rub these. Okay, so we had A, B, A, A. Okay, we had to replace BB. First is in the first place, so it will be converted to BB, A, A. Basically, BB has to be inserted in the first index, starting from the first or the 0th index, right? So BB, what is the cost of doing that? You are actually replacing A to B only. So the cost here involved is 1. Let's go to the second place. We want to replace here BB, right? We want to convert this to A, B, B, A. That is, B starts off at the first index, 0th index, and after that first index, right? So here bb was replaced as 0th index, here we are replacing at first index, right? So the cost here again will be 1 because one of the a is converted to b, so 1. Now we are replacing in the second index, so it will become ab bb, right? And the cost here involved will be 2 because both the a's are converted to b's, right? So we see these are the three these are the three places where bb can be there, right? No other place we can have bb together, right, as a substring. We cannot have bb anywhere as a substring in any other place. I hope that you agree with this, right? So once we have that, we have to, once we are done with this, right, once we are computed this, we have to check what is the minimum cost to convert this to a palindromic string, provided you cannot replace this bb anymore, because bb is a substring. So if you are converting this to a palindrome, you have to make sure that this bb is not replaced, because S2 you will not change, you can only change S1, right? So BBA, what is the cost to convert it to a palindromic substring? The nearest palindromic substring will be BBBB, right? So 2 more plus 2, so the total cost involved for this will be 3. 2 plus 1 will be 3. So the total cost involved here will be 3, right? So let's write down 3 here. So the total cost to get this palindromic string BBBB is 3. Let's come to the second case, right? Let's come to the second case. So ABBA, this is already a palindromic string, so we don't have to incur any other additional cost to convert. So the cost here will be 1. And for the third, we have to convert this to B. So it will again become BBBB, and 2 plus 1 will be 3. The cost will be 3. So the total cost will, minimum cost possible will be 1, which is the answer to our problem, right? So this is how we will do, and this is exactly how we'll do. This is how we'll replicate in our code as well. I hope that the logic clear with everyone what we are doing. First step is we'll replace this bb second string as a substring. So we'll, for all possible places where if we can replace bb as a substring, we'll try to do that. In the generated string, now we'll try to convert this to a palindrome, but we have to be sure here about one thing, that we do not change any of the replaced characters for the second string, right? Whatever is the second string there, we do not change any of the characters there. We can change any other character, but we cannot modify s2, right? We can only modify s1, so we cannot change that. So this is what we will do. So let's look into the code, and this is the entire solution, right? This is not very complicated. Let's see how do we implement this. So I'll go to a full screen mode here. Okay, s1 and s2. First thing that I'll do is I'll take n and m. the string length. So n equals to s1 dot size and m equals to s2 dot size, right? Okay, s1 dot size, s2 dot size. Now what is the, I'll try to insert in all possible indices. What is the last index that I can go up to? I can start up at 0. I can start my replacement at 0th index, like the second string will be starting at 0th index in first string. What is the last point I can go up to? I can go up to n minus m plus 1, or I can go up to n minus m. To be more specific, I can go up to n minus m, right? So this is the last one, because the string 2 has a length of m more, right? So if we go beyond that, it will actually overshoot the length, overshoot the string 1 length. It will take more characters. We cannot add more characters. We can just replace the characters of s1, right? So we can go up to n minus m plus 1 I plus plus. Okay, so what is the string that we have generated, or what is the string that we have generated till now? So let's call it a string s. String s equals to what? It will be s dot sub str. We can take out substring like this, or you can do it manually as well, like just by running a loop. S1 dot sub str will take this first I characters 0 to I. After that, what is happening? After that, s2 is coming in, right? So plus s2, plus after that, what is the remaining characters? The remaining characters after that are remaining. So s1 dot sub str, what will be remaining? I plus m to the end. So you don't have to specify the end actually. So it means that you are taking away the first I characters of s1. After that, you are placing s2, because s2 begins at the ith character. Now s2 is occupying m characters, right? So after that, the remaining characters, that is whatever characters are remaining after that, those m characters are taken. So I plus m, from that to the end, they will be again added, right? So s1 dot substr 0 to I plus s2 plus s1 dot substr I to I plus m. I plus m means I plus m to the end. So it will take all the characters after I plus m. So this is the string that we have. Now first thing that we'll do is we'll try to find what is the cost to have this. Also, we'll have our answer here, right? Now can you tell me what is like here? See, we are trying for all possible positions. Now definitely we should initialize our answer with something that is never possible. So what is the maximum number of changes that we can do? In maximum, we can change this entire s1, right? We can change this entire s1. So in maximum, we can at max make n changes. We cannot make more than n changes. So we initialize our answer with n plus 1, right? And what will return? Will return if answer is greater than n. If answer is greater than n, in that case we'll return minus 1. That is, we cannot form a palindromic substring. Otherwise, we'll return our answer, right? So n plus 1, it is not possible to have n plus 1 changes, right? Because you will be changing each character, and each character you will always try to change it so that it actually makes sense, right? So you will not change unnecessarily. So basically each character will be changed only once. So as there are n characters in s1, so that's why n plus 1 will never be possible. So if the answer is greater than n, you can return minus 1, otherwise it is the answer. Okay, so cost is here, cost equals to 0. Now let's yes, Sriram, good. So int cost equals to 0. Now what we'll do, we'll see what is the cost that has been incurred till now to replace this s2, right? To convert like to add this s2 into string. So what is the cost there? So for int j equals to 0, j less than m, j plus plus, m characters have changed, right? At max m characters have changed. So we'll check here if s1 of s1 of I plus j is not equals to s2 of j. If s1 of I plus j is not equals to s2 of j, that means it has undergone some change. So that means we'll do a cost plus plus. So we are changing from the ith character. So j equals to 0 means ith character, then j equals to 1 means first character, like that up to m characters. So it will compare all the m characters from I, and it will check if it has undergone a change or not. So s1 of I plus j is not equals to s2 of j, right? So it will check like this. Thanks, Sriram. So okay, let's go ahead. Right now this part is done. Now comes the interesting part. We have to convert this to a palindrome. Now we come to the part we have to convert to palindrome. convert to palindrome. Now we have to be sure about some things, right? So whenever we convert something to palindrome, how do we do? Like, how do we check for a palindrome? We run two loops, one from the front, one from the back, and we check character by character, like zeroth character with the last character, first character with the last but one character. Like this, we combine one by one. So we'll do the same thing here as well. For in j equals to 0 and k will be equals to what? N minus 1. J less than k and j plus plus and k minus minus, right? Will come from both the ends. That is how we check for palindromes. Will come from both the ends. Now this will be actually a bit tricky here. First thing we have to check. Okay, before we start with this, let's actually define two more variables. That is, what is the range of the h2? What is the range that h2 is taking in this string, right? So what is the range? So starting will be equals to what? It will be I. h2 is starting from I, and the ending point will be what? I plus m minus 1. I plus m minus 1. So h2 is from the index I to I plus m minus 1. Why do we need this? Because although it is not needed to be like taken in a separate variable, but it just makes the explanation easier, because we will make sure that when we are converting it to a palindrome, we should not make changes to h2. So that's why we'll need this, right? Also, we'll take one more variable. Is palindrome possible, right? Is palindrome possible? It will be initially true. We'll mark it as true, and if it is not possible, we'll mark it as false. Okay. How about running a loop half the length? Yes, definitely you can run a loop from half for half the length as well. I kind of prefer this way because I can visualize this better. But again, that same thing, right? You can definitely do this way as well. Okay. J equals to 0, k equals to n minus 1, right? Okay. So coming to the first part, if both j and k are within the range, if both j and k are within this range, that is, they are both inside h2, they are both inside h2 range, that it the range of h2 that it occupies in the string, right? They're both within that. So if both inside, that means both are actually inside the range of h2, right? That is, if, what is the condition? If j greater than equals to start, if j is greater than equals to start and j is less than equal to end and k is less than equal to end, and actually this is enough. We don't need k is greater than equal to start. Why? Because j is always less than k. So if j is greater than equal to start, k will also be greater than equal to start. So basically this tells that both the pointers I and j and k are inside the range where h2 is there. So we cannot make any changes here. So here we'll add a condition. If what? If s of j is not equals to s of k, if s of j is not equals to s of k, then we cannot do anything, right? We cannot do anything. Why? Because we are inside the range of h2 and we cannot change h2. We are within the range of h2 where it is there in the string that we have generated, and we cannot make any changes. So it will not be palindrome. Whatever we do, it will not be palindrome. So what we'll do, we'll mark it as is palindrome possible to be equals to false, and we'll break it here, right? No, both, it will not reduce, right? I'm increasing as well as decreasing, and I'm going to tilde j less than k. So it will eventually end up at n by 2, right? Both will end up at n by 2 because both are incremented as it is incremented by 1, it is decremented by 1. So both will meet at n by 2, right? So is palindrome possible will be marked as false and will break because we cannot make this a palindrome. Otherwise, this is interesting, right? Otherwise, one of them is outside, right? One of them is outside the range of h2. That means we can change that character. Be it j, be it k. Whoever is outside, we don't care. We can change that character. One of them we are flexible about. The other one we might not be flexible about. But we need only one of them to be flexible about, right? Because let's say there is a b inside and there's a c, like there's a c which is outside. K is c and j is b. The jth character is b, kth character is c. Now b is inside, right? B is inside, but it is outside. C is outside. So we can just flip the c to b, right? So we don't care about that. So if that's the case, if s of j not equals to s of k, we'll just do count plus plus. We'll just flip that cost plus plus. Sorry, we'll just flip that character, right? Now here we'll make a check outside this loop. We'll make a check that if palindrome was possible. So is palindrome possible? Is palindrome possible? In that case, our answer will be equals to minimum of answer or whatever the cost that we have, and this is the code. What if S2 is greater than S1? Can that be possible? It is not possible, right? S2 in the constraint, S2 is less than S1. It is not possible. So we can check directly S1 as a palindrome. No, we are not actually checking S1 as a palindrome, right? We have to convert S1 to a palindrome. Now we have to be sure about, because okay, the string that we have generated is not S1, right? The string that we have generated is which contains the first I characters of S1, after that S2, and after that the remaining characters of S1. Remaining means I plus M, like the M characters are gone, they are replaced to S2, and then we have to convert this S to a palindrome. But we have to also maintain the fact that we do not change any characters that are there in S2. This range, whatever characters are there, we do not change any of them. So that's why, how do we check for palindrome? We run two loops, right? Like this, we go one from the front, one from the back, we combine character by character. So we do that, but we also have to make sure that S2 characters are not changed. So for that reason, we have this loop. We check that S2 characters are not changed. So if there is some inequality there, we'll just mark is palindrome possible is false. We cannot make a palindrome anymore. So we'll break, right? Otherwise, we will add to our cost. We'll just add to our cost. So I think this should work. So let's compile and run. Okay, my output is, I don't know, hopefully it works. Let's see. Okay, so it's done, right? Problem solved successfully, but it's showing 0 because I've already solved this before. Got it. Okay, got it. Cool. Any doubts that you have with this problem? Any doubts that you are facing? Yes, it is order of n. It is order of n. So what is the total complexity? The total complexity, the outside loop is running for n into n minus m or n, right? The inner loop, it will run for n, so it is n squared. Again, this part will run from run for m, so this loop will run for m, so it is n into m, and this is again for n, so n squared. So it is basically n squared plus n into m. So whichever is the maximum, that that will be taken, right? So that is the complexity, n squared plus n into m. Cool. Thanks, guys. Can we move to the next problem? Is this clear with everyone? Let me know if it is clear with everyone. Then we can move to the next problem. Could you please explain? I'll definitely talk to the team. Let's see. But again, like the others also explained very well, so they might take some of them. I'll also try to take some of them. So it will be a mix and match. Cool. Any doubts that anyone has with this, or can we move to the next problem? Harsha, yes, I agree with you. But actually, I think there has been some mistake, right? So it can be like it should have been done n square or n into m. But if you see the constraint, both of them are same, like 100,000 square. So yes, I agree there has been some problem here, but it should be order of n square, max of n square comma n into m, not that, right? How can we convert string to palindrome if possible? How can you convert a string to a palindrome if possible? How can you do that? Let's see. So let's clear this board. Okay. So let's say you have a string like this, A, B, C, D. You have to convert this to a palindrome. So you start with 2 pointers, right? Okay, so you have A here, you have D here. Either you change this to D or you change this to A. So you can just change this to A. Let's mark them with green, right? So we'll just change this to A, right? And then we'll move forward one place, move backward one place. So BC, either change this to C or change this to B. Let's say we change this to C. So C, we have landed up to a palindrome, A, C, C, A. So this is how we can convert a string to a palindrome. We run two loops, we check if they are not equal. If the two characters are not equal, we flip one of them to be made equal to the other one, right? So it will become ACC and the cost incurred will be 2. Okay. Please try to do the next question without try approach. Try. I'm not sure how can we do it with try. Okay, let's move to the next problem. Let's go. Okay. Greater or lesser, right? You don't need to read input or print anything. Okay, that is unnecessary. We have a function greater lesser which takes an array and has input parameters and returns the required array, right? So it will take, what will it do? I think okay. Given an array of size n, for each ith element in the array, calculate the absolute difference between the count of the number that are to the left of I and are strictly greater than the ith element. So that are on the left side of I and are greater than ith element. So on the left side, we are checking for number of elements greater than I in the left side, and the count of the numbers on the right of I that are strictly lesser than the ith element. They are strictly lesser than the ith element. So the number of elements on the right hand side that are lesser than the ith element. So we have to do this, right? I'm pretty sure that most of you already know how to solve this. So whenever you have something like you have to count the number of greater elements on the left or on the right, and those things like count number of elements in some range, you have to go to a range query data structure, right? So the most common range query data structure is a segment tree. You can also use a binary index tree if you want. We'll see how we can use a segment tree, but before that, the constraints, right? These constraints are important. The constraints are important. Minus 10 to the power 9 less than equal to ARR of I less than equal to 10 to the power 9. So we cannot. Okay, let's, before that, we'll discuss the idea about how do we create on what property we want to create a segment tree, and then we'll discuss about this constraint a bit more, right? Okay, let's start. So I'm assuming I'll not be teaching you about segment tree, what segment trees are. I'm assuming that you guys already know about segment trees, so I'll not be teaching about that. If you don't know about segment trees, I'll definitely encourage you to read about segment trees before actually watching this. But again, we'll not be learning about segment trees, right? We'll be discussing about the solution. Okay, so let's start. Okay, we have to find, just let's focus on one of the problems, like number of elements on the left that are less than or greater than. It was greater than, right? So number of elements on the left that are greater than the current element. I think on the left, number of that are strictly greater than the ith element. Okay, that are strictly greater than the ith element. So on the left side we are computing greater than. It will be same like on the right side we are computing lesser than, but the technique will be completely same. It will be just a difference of greater than and lesser than. Basically the difference of what the segment tree will contain. It will contain the max versus the mean, or sorry, not the max versus the mean, but the range of the segment tree query will be different. Sorry, my bad. Both of them will contain the count. Everything will be same, only the query range will be different, right? So for optimal solution, I thought of calculating difference between index original was, but I had no luck. No, I don't think it will be very that simple, because here you have to find only the elements on the left, right? You have to find all the elements on the left that are greater than or lesser than, right? So all the elements on the left and all the elements on the right that are lesser than. So like that, you cannot, if you're sorting it, actually you are losing the actual value of the position. So you cannot do using sorting or something like that, a trick like that. So what you should do is, let's actually take an example, right? Let's take an example. So I'll not build the segment tree here, but I'll give you the idea about how the segment tree is constructed. So let's take an array here. 2, 1, 3, 2, 4, 5, 1, 3, right? So let's take this 2, right? Let's take this 2. How many elements are on the left hand side that are strictly greater than the 2? So on the left hand side, what are the elements? 2, 1, 3. Out of them only one element is strictly greater than 2, that is 3, so the answer will be 1, right? For the left hand side. For the right hand side, it will similarly how many elements are greater on the right hand side, but we'll not focus on the greater part right now. Okay, let's focus on this part, left part, greater than on the left side. Why are we not inserting at line 20? Why can we not replace? If we replace the string, I think you were talking about the previous problem, but if we replace the string, it will actually like modify the existing string, first string, right? So we cannot replace. We don't want to modify the first string, so that's why. Okay, anyways, let's come to this. So what we'll do here is, first thing is left, right? We have to make sure that the elements are on the left. Let's say we are traversing the array from left to right. We are traversing the array from left to right and we are inserting into the segment tree. When we reach this 2, what are the elements that are there in the segment tree? Yes, yes, Nitun, we have to do something like that only. Okay. So when we are traversing from left to right, we reach an index I, right? We are reaching an index I. What are the elements that are there in the segment tree? Can anyone tell? What are the elements that will be there in the segment tree? We are traversing from left to right. What are the elements that will be there in the segment tree when we reach this 2? Can anyone tell? Can anyone tell? If you are moving from left to right and you reach this index I, what are the elements that will be there in the segment tree? And you update as you go. You update as you go, right? So you come to 2, you update the occurrence of 2. You come to 1, you update the occurrence of 1 in the segment tree. So when you reach this I, if you look carefully, you will only have the elements 2, 1, 3. That is the elements on the left, right? You will just have in the segment tree 2, 1, 3. That is the elements on the left hand side. So this left hand constraint is gone. What I'm saying here is, whenever you visit an element, you update in the segment tree, right? You don't update before that. You update as you go. So you update in the segment tree as you go through one of the all the elements. So when you reach I, only the elements on the left hand side of I will be there in the segment tree. Only the elements will be. Is this clear with everyone? Is this clear with everyone? Can anyone tell, is this clear? Is this clear with everyone? Like, why will the elements on the left hand side be only there? Segment tree, Fenwick tree important for Microsoft. I cannot tell like that. Like, definitely, generally they don't ask, but it might be happen that the interviewer actually asks you such a question. Like, it's not out of the syllabus. It's not out of the syllabus, but generally they don't ask. Nitun, I don't think you can use a map. You can try, definitely. If that works, you can definitely reach out to me and tell me. At least I don't know a solution that actually we can do like that. I tried doing that, but I don't think it will work. But yeah, like, you can definitely send me the code. Okay, so is this clear? Like, when we move from left to right, we are updating as we go. Only the elements in the set will be 2, 1, 3. Like, on the elements on the left hand side, right? Only these elements will be there. Okay, so I'm assuming that this is clear with everyone. So this reduces the constraint of elements on the left, right? This reduces the constraint of elements on the left. Now we have only one constraint, that is greater than, right? Now this is where the interesting part comes in. Whenever you have to find something like number of elements greater than the current element, right? Number of elements less than the current element, right? What is the type of segment tree that you will create? So you want to find the number of greater elements, right? Greater than elements, right? Isn't it same as finding the count of the range ai plus 1 to the max value? Isn't it same as counting the number of elements in the range ai plus 1 to max value? So whenever if you see a element, so your update operation will be like, whenever you see a element, you will update in the index a of I with plus 1. You will update in the index a of I with plus 1, right? So that means you basically want the count of number of elements in this range, right? So if you're updating with plus 1, right? At index a of I, this range will give you the sum, that is the number of elements greater than the current element, right? Greater than the current element. Is this clear with everyone? How we are constructing the segment tree? So on Go, we can also use upper bound by inserting previous element in set. Previous element in set. Previous. Okay, so you are inserting elements into the set, and you are using upper bound. Huh. Yes. I think that should work. Lower bound, upper bound should work. But number of elements, how would you compute the? I don't think. Can you find the number of elements? Like, can you find that if you use the distance, there's a distance. You will get the pointer. You will get the pointer or reference to that element. But how to compute the number of elements? You have to use something called distance, which is actually order of n in set. That actually would give you the pointer, but I think the distance will cause the problem. Number of elements, right? So you have to update a of I. Is this clear with everyone? You have to update a of I with +1, index a of I in the segment tree with +1. Duplicate, it doesn't matter, right? A chain set duplicate, yes, you can use a multi-set, but again distance will become problematic. The number of elements, basically. I don't think you can find the number of elements from a given pointer, because it's not an array, right? It's a tree-like data structure. So it will be order of n. Anyways, I might be wrong there, but again, like, do check that out. Okay, so you will be querying in the range a of I plus 1 to max. I'm assuming that this is clear with everyone. Okay, so now the problem is, we see that in the segment tree the index will be a of I. In segment tree, a of I will act as the index. But if a of I acts as the index, the constraint that is given to us is what? It is 10 to the power 9 minus 10 to the power 9 to 10 to the power 9. So we have the constraint minus 10 to the power 9 to 10 to the power 9 of a of I. How can a of I act as the index? How can vector, how will you store it sorted way? You have to sort every time, right? So it's anyways n square. So a of I minus 10 to the power 9 to 10 to the power 9. So your segment tree is essentially becoming size of 4 into 10 to the power 9 approximately, right? Or 2 into 10 to the power 9, whatever approach you're using. So definitely this will not work. How to get this working? This is the approach that we'll use. But how to get this working? Because the constraint doesn't fit us. If you look into the question carefully, what has been asked is only you want to know whether an element is greater than an element or whether an element is less than an element. You don't care about its actual value. You don't care whether it is 10 to the power 8 or it is 10 to the power 7, right? You only care about the fact that 2 is less than 10 to the power 8 or 10 to the power 7 is less than 10 to the power 8. You just care about this fact. You don't care about the fact it is 10 to the power 7, it is 10 to the power 8. So that whenever these things happen, whenever you don't care about the actual values and you have a huge range, what you can do is there's a technique called coordinate compression. There's a technique called coordinate compression. There's a technique called coordinate compression. What does it do? It will compress the values. It will compress the values within the range of n. It will compress the values within the range of n, and the relative order will remain the same. I'll give an example here. Let's say we have an array like this. I'll make the array sorted. It doesn't have to be sorted, but the concept will be same. Let's say we have -2, -1, 4, 100, 600, something like this, right? Coordinate compression, what it will do, it will convert this to an array. -2 will be becoming 0, -1 will become 1, 4 will become 2, this will become 3, 600 will become 4. So see, the relative order remains the same. You are compressing 600 down to 4. The relative order of 4, 600 and 100 remains the same. That is 600 is greater than 100. That is 4 is greater than 3. But their values are compressed. Right? So we can use this coordinate compression technique to and we don't care about the actual values. We have already established that. We just care about if an element is greater than an element or if an element is less than an element. So we can use this coordinate compression technique to compress all the values within n, and then we can create the segment tree. then we can create the segment tree. So coordinate compression happens in this way only. We'll take all the values out, we will then map them in the range 0 to n, right? There are n values, so they can be mapped in the range 0 to n, and for equals they will get the equal mapping, and then we can build the segment tree. Like the array will be changed to 0 to n, basically from minus 10 to the power 9 to 10 to the power 9, we'll change the array to 0 to 10, 0 to n minus 1. So this is what we'll do. Now we can create the segment tree out and quickly answer to the problem, give answer to the problem. Is this clear with everyone? We can move to the code then. Is this clear with everyone? What have we discussed? So the first part will be for the segment tree, we have realized that we can use the array elements as the index, and then we can keep query on the range of, like if it is less than a of I, then we can query on the range 0 to a of I minus 1. If it is number of elements greater than a of I, then in the range a of I plus 1 to n, like that, right? So that will be our query range, and we can use coordinate compression as well, right, to compress the values from 10 to the power 9 minus 10 to the power 9 to 10 to the power 9 to 0 to n minus 1. So we can use this technique. Okay, so whenever you have such a question where you see the element values are very high and you don't care about the element values, you just care about the relative ordering, so you can go for this coordinate compression technique. Okay, so first of all we'll do this, but before that we have to store the compressed values as well, because on top of that we'll create, so vector will literally rewrite the values, right? So what we'll do here, we'll make the changes in A itself, right? So what we'll do here, we'll maintain a map here, map intint compressed values. So in cnt equals to 1. So this will maintain, or this will maintain what is the, or let's give it a number, int number equals to 1, compression number or something like that, right? So number equals to 1, let's call it compression number, otherwise it might be comp num. Okay, compression number. What we'll do, we'll go through all the elements one by one. So for int I equals to 0, for int I equals to 0, I less than n, I plus plus. So if compressed values, right, if compressed values of a of I, compressed values of a of I, if it is equals to 0, that means we haven't assigned any value to it, or you can use the dot find operation as well. If it is equals to 0, then we can give it a value here. So compressed values a of I is equals to comp num plus plus, is equals to comp num plus plus, right? So we give it a value and then we increment it. Also we have to have this in a sorted way, right? This will be wrong, the relative ordering will be destroyed. So let's take a b which will be equals to a, and we can sort b, right? Sort b dot begin, b dot end. So we can just sort b, and then we can loop on b. So we have sorted the values and we have compressed them as well. So the relative ordering remains the same as we have sorted them and then given the numbering, right? So the relative ordering remains the same. So now we'll change the array a itself. So for int I equals to 0, I less than n, I plus plus. So a of I will be equals to compressed values. So compressed values of a of I, right? So we'll change the array a itself. Now what has happened is a has all the elements within 0 to n. So a of I, all the elements will be not 0, 1 to n actually, greater than equal to 1 and less than equal to n. So all the elements will be within 1 to n now, right? And this is called coordinate compression. So we have compressed all the values within 1 to n. Now it's time for us to create the segment tree, right? We'll create the segment tree. Okay, so I'll not teach this right now, but I think like most of you already know how to create segment tree, or you might be using a recursive segment tree already. But again, like when it comes to a coding contest, it might be a bit overwhelming to write the code of a segment tree like the recursive version, right? So you might want something simpler or easier. Although recursive version is also not that difficult, but if you want something a bit simpler, you can definitely go for an iterative version of the segment tree. You can definitely read there is a code forces blog. You can just search on Google that iterative segment tree code forces, and you will get a blog on that. You can definitely read up on that. So there's an iterative version which is pretty easier to code as well. So maybe we can go with the iterative version code as well. Can you dry run this code with just 4 elements? Sure, I'll dry run with 4 elements. I'll definitely do that. So let's first understand the code, and then I think it will make more sense, and then we can definitely dry run, right? So let's call this class a segment tree, right? And we'll create a vector in segment tree, and in the public portion we'll create the constructor segment tree, and we'll pass in n. We'll pass in n. So it will also store the size of the segment tree n here. So n equals to n. Sorry, n equals to n, and n equals to n, and it will create a segment tree. A segment tree equals to vector int. It will create a new segment tree here. For the iterative version of the segment tree, we just need 2 into n space. For the recursive version, we need 4 into n space, as you already know. But for iterative version, we just need 2 into n space. So I'll go with the iterative version. So 2 into n, and initially everything will be 0, right? So that will be there. Now first is update. So update, we are given an index, and we have to add +1 to that index, right? We are given an index, we have to add +1 to that index. So segment tree index plus n, this is the position where actually it is present, the node is present. Oh, okay, coordinate compression you have asked. Okay, sure, coordinate compression, I'll give an example here. Definitely, just give me a second. Clear canvas. So let's take the part of, let's take a part, unsorted array, right? So let's take something like, we have an array like this: 400 minus 1 600, right? 400 minus 1 600, this is A, right? First, what we are doing, we are copying this in a B. So B will be equals to 400 minus 1 600. Then we are sorting B as well. So B will become, after sorting, B will become what? B will become -1 400 600, right? Now what we are doing, we are going through all by them one by one, and we are giving them a compression value, right? So if you see the loop, for I equals to 0, I less than n, if it is equals to 0, if it is not there in the map, then you will give it a comp num plus plus, right? Comp num starts from 1. So we'll give it, we'll keep the comp num here variable, comp num equals to 1, and we'll also keep the map here. Map is here actually, let's call it map only. So initially map is empty, right? We get -1, so -1 is not there in the map, so -1 will get the value of 1, and comp num will be incremented to 2, right? Now we'll move to 4. So let's say there is a duplicate here. Let's say there is 4 here as well, right? So we will have 2 4s here. Now 4 is not there in the map, so it will get, we'll add it to the map, and it will get the value of comp num, that is 2, and comp num is incremented to 3, right? Now we have a 4 again, so it will again get the value of 2 only, because it is not equals to 0, we'll just skip this. Now 100 will get the value of 3, and comp num will be incremented to 4, and 600 will get the value of 4. So now you basically change this array A to 4. 4 becomes 2, right? 4 becomes 2, 100 becomes 3, -1 becomes 1, and 600 becomes 4, and 4 becomes 2 again. So see, isn't this array and this array same with respect to number of elements on the left that are greater than, or number of elements on the right that are less than? Aren't these two arrays same? Aren't these two arrays same? Sriram, is this clear with you? So we have basically compressed it into a order of n. The size will be order of n. So 4 becomes 2, right? 100 becomes 3, 1 -1 becomes 1, 4 2. So see, the ordering remains same. 4 के बाद 100 है, so 2 के बाद 3 है, greater है, right? After that -1 is there, so 1 the least element. After that 4 is coming in, the greatest element. So this is how it is, like how coordinate compression works actually. So what we'll do here, okay, so I was talking about segment tree. Now if you don't understand the segment tree code, you don't have to worry about this. this is just a iterative code. You can definitely write the similar recursive code, right? There's nothing changing here. So it's the normal update function that we write in a recursive segment tree, right? Segment tree index plus n plus equals to 1, and for, so let's just increment index to plus equals to n. So index plus equals to n, and segment tree of index is this, and index greater than 1 and index divided by equals to 1, and segment tree of index by 2 equals to segment tree of index plus segment tree of index or 1. Basically left and right child we are combining here, right? This is the left child, this is the right child. One of them is the left child, one of them is the right child, and their parent is at I by 2. So we are just combining their combining them like this. So this is the update code. And see, like, this code is very less, right? It is just in like 4 lines and so simple loops. You don't have to worry about recursion, so many parameters and these things. Just one parameter and 4 lines of code. So that's why I prefer this actually, and it will be actually void update and int query. Now this is actually a bit interesting here. Query will be equals to, you will given a range int lr, and your query range will be, you are finding in the range L to R exclusive. Remember this, you are finding in the range L to R exclusive. R should not be there in the answer. R should be the answer plus 1, like kind of the end. Okay, could you explain in Python? Sorry, I'll zoom in. Python, sorry, I can't explain right now in Python because I'm using C++, but definitely will get the code for Python in the editorials or those things, right? What matters is the concept. So once you get hold of the concept, you can definitely look into the code, right? So in query lrn, so L plus so how do we write the query code? So L plus equals to n, R plus equals to n, we start from here, and res equals to 0. Or we can write in the for loop as well. I think it's better. It's cleaner to write in the for loop. So I'll just erase this part. Res equals to 0 for L plus equals to n, R plus equals to n, L less than R, L divided by 2, R divided by 2. So if L is odd, we'll add it to the answer. If L is odd, then res plus equals to st of L plus plus. Res plus equals to st of L plus plus. Now this is interesting. If R is odd, R is not included in the answer, right? R is outside. So we will do res plus equals to st of minus minus R. We'll pre-decrement it. So R is not there in the answer, so we'll take the previous value of R and then we'll pre-decrement it, right? So, and we can return res here. Return res. You can reach out to me on LinkedIn. इजी कोड बताओ, ये नहीं इजी कोड, ये इजी सबसे इजी कोड यही है. मैं मतलब इफ यू वांट आई कैन राइट द रिकर्सिव कोड एज वेल, बट इतना सारा पैरामीटर्स पास करना है. शुड आई राइट द रिकर्सिव कोड? शुड आई राइट द रिकर्सिव कोड? शुड आई राइट द, ओके चलो चलो रिकर्सिव कोड करते हैं, चलो कोई बात नहीं. So before that we'll define something, m equals to beginning plus end by 2, beginning plus end by 2, है ना? We'll use this to compute the mid. Basically mid, instead of writing every time, we'll just define it here. Mid equals to beginning plus n by 2. Chalo, recursive karna hai, to 4 into n will be the size. Update, what will be the elements that will take in the update? So int the range L, int R, int index, and int pos, right? So if L equals to R, then st of pos plus plus, and will return. So if index is less than mid, so it is in the left child, index is less than mid, that is L plus R by 2. So we'll write here instead of beginning end, we'll write here L plus R by 2, right? L plus R by 2. So index is less than M. No, it cannot be done without segment tree. It can be done using binary index tree, but not without, like, some range query data structure will be needed. So st pos plus plus, and if it is there, so we'll call update on the left child. So update L. Okay, so update will be L mid index pos. Sorry, 2 into pos plus 1. So 2 into pos plus 1, and else we'll call update on the right child. So update mid plus 1, update mid plus 1 end, mid plus 1, sorry, r, index 2 into pos plus 2, and then we can do it st of pos equals to st of 2 into pos plus 1 plus st of 2 into pos plus 2, right? Segment tree is a must. Segment tree is a must. You cannot do without segment tree. So LR, now here it will be actually QL So QL within the entire range of segment tree. So what will we take? Let's remove these things. So the parameters that we'll take here is int L, int R, also the query range QL, QR, and pos, right? So this is the query range we'll take. So if QL less than equal to L, if it is within the query range, that is QL less than equal to L and QR is greater than equal to R. So if it is within the query range, then we can return the answer. So return st of pos, right? Return st of pos. Else if QL greater than R, if it is outside, or QR less than L, then we'll return 0. Else return query of L to R, QL to mid, and 2 into pos plus 1. We'll call the left child, plus query mid plus 1, m plus 1 to R, QL sorry L to R क्यों लिखा मैंने, L to mid, QL to QR, sorry, QL to QR, 2 into pos plus 1, mid plus 1 to R, QL to QR, and 2 into pos plus 2. We'll just return this, right? So this is the segment tree code. This is the entire segment tree code that we need. So okay, so this is the entire segment tree code. Now we'll start, we'll compute our answer. So int answer, so answer will be an array, right? So vector int answer in 0 of size n. Now we'll go through all the elements one by one. So before we compute the answer, we actually need the left computations and the right computations. Left and right, vector right, lesser, greater in left and lesser in right, I believe. So n0 will need both of them, right? So for int, so let's create a segment tree first. So what is the class name? Segment tree, right? We'll create two segment trees, right? We'll create two segment trees. Segment tree st1, and we'll pass here what? We'll pass here n. N will be equals to whatever is the value of comp num, that is n for us, right? Whatever is the value of comp num, that is n for us. And segment tree will create a st2, and whatever is the value of comp num, that is the n for us. So comp num. Okay, so that is there, left and right. So for int I equals to 0, I less than n, I plus plus. So we'll query, right? First is we'll query number of elements on the left that are less than greater than the given element, right? So our query range will be st1 dot query. The query range will be 0 to comp num minus 1, 0 to, and the query range will be what? Query range will be number greater than, right? So it will be equals to a of I plus 1, a of I plus 1 to comp num minus 1, right? That is the maximum value, comp num minus 1 and initially 0, and then we'll update in the range 0 to comp num minus 1. The index that will update is basically a of I, and pos is 0. So st1 dot update, sorry, st1 dot update. So we'll update like this. Bye Shriram, good night. So st1 dot update will update. So we are basically updating on AI, and our query range will be then AI plus 1 to comp num minus 1, because we want, what do we want? Number of elements, right? We want number of elements on the left that are strictly greater than ith element, and count of number of elements to the right that are strictly lesser than ith element. So count of, on the left we want count of number of elements strictly greater. So our range of search will be ai plus 1 to comptum minus 1, where comptum minus 1 is the maximum value possible. Instead of comptum, you can write here max as well, like you can take this variable as max as well. Okay, so this is the first part, and for the second part we'll run a reverse loop so that only the right elements are focused. So I equals to n minus 1, I greater than equal to 0, I minus minus, and what we'll do, right I equals to lesser element, right, number of elements less than the given element. So st2 dot query will use a different segment tree right now. In the range of, first is the segment tree range, so 0 to comptum minus 1. Then in the range of this, right, in the range of what, 0 to a of I minus 1, strictly lesser, 0 to a of I minus 1, strictly lesser, right, and 0 to a minus 1 and 0, and st2 dot update 0 compnum minus 1 a of I and 0. Okay, now finally we'll compute the answer. So vector int answer and n0 for int I equals to 0, I less than n I plus plus, answer of I equals to abs of right of I minus left of I, right of I minus left of I, and here we can return answer. So I hope that this will work. So this is the entire code. Let's see if this is working. There might be some compilation issues, so let's figure them out. Okay, it's working, I think. 313. Okay, what is the expected output? Can I not minimize this? Okay, 54321, and the output is 42024. 42024. So something might be, we are missing something. We can see the required number. Okay, for the first element 5, number of elements on the left is 0, number of elements on the right will be 4, less will be 1 2 3 4, so it should be 4. Why is it returning 3? So let's see why is it returning 3. Answer of I, okay, right of I equals to st.2 dot query comp num minus 0 to a of I minus 1. That is the range we are searching for. That's perfect. And we are updating a of I, right? We are updating a of I, so it should be updated. And left of I, for left we are using st1, right? St1 dot query st2 dot update. Okay, st1 dot query 0 to comptum a of I plus 1 to comptum minus 1 and 0, and st1 dot update. And what is the range we have created? 0 to comptum. Okay, comptum up to comptum we have created invis comptum, and that is what we have. Is it clear with everyone? Is the logic clear with everyone? We'll try to debug, but let me know if the logic is clear with everyone. So update l r index plus l equals to r, segmentary pos is plus plus, we'll do plus 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 because it will be incremented, and return if index is less than the mid, we'll update on the left. So left to mid index and 2 into pos plus 1, otherwise mid plus 1 to right, index 2 into pos plus 2, st pos is st2 pos pos plus 1 plus 2 into pos plus 2. Query is ql less than equal to l if the query range is within, if the current range is within, qr is greater than equal to r. So l is ql is less than, okay, it is on the left, and qr is greater on the right. Okay, is return st of pos if ql greater than r or qr is less than l. Okay, ql greater than r, yes, it makes sense. 0. Return l mid ql qr 2 into pos plus 1, mid plus 1 r ql qr 2 into pos plus 2. Okay, and compression part, compnum equals to 1, b equals to a, will sort b and n I plus plus, values of b of I equals to 0. We'll see compressed values b of I equals to compnum plus plus. Is it clear with everyone? Let me know that meanwhile in the chat. A of I equals to compressed values a of I, we are changing this. Okay, left and right, and less than n, st1 dot query 0 to compnum minus 1. Instead of compnum, let's actually make it something else. Let's call it max, right? I don't like the variable name CompNum, so I'll just write it as max plus plus. We can create an array of size max. Here also it can be max and left right. Okay, query 0 to max minus 1, that is the range. A of I plus 1 to max minus 1 on the left, right? 0. st1 dot update 0 to max minus 1, a of I 0. Yes, a of I 0. Yes, a has been changed actually. Okay, st2 dot query max minus 1 0, a of I minus 1 0 to a of I minus 1 is the query range for us. 0, and finally we'll update at max minus 1. So max. Okay, I think we have got rid of CompNum completely. Answer is ABS left, right of I, left of I. Let's add a logging statement to understand better which one is not working. So right of I, and we will give a space and we'll print left of I as well, and we'll give a new line here. Okay, so let's try to understand which one is not working for us. Okay, completed. So if we see, for 5 it is 3 on the right, 3 on the right. Okay, and everything for 4 it is 2 on the right. Everything has one less, everything has one less. Why is the one missing? 0 2 4 1 2. Okay, let's actually print this compressed array as well. So the a of I that we have, for int I equals to 0, I less than n, I plus plus, c out a of I and c out slash n. A of I should be 1 2 3 4 5 only, I think. Okay, a of I is 5 4 3 2 1, because all the elements are 5 4 3 2 1. So this is good, right? Something is wrong with the segmentary part. So the range will be max should be 6. Max should be 6. Let's see if the max is 6. C out max slash n. Max should be 6. Max is 6. Okay, max is 6 for us. Okay, left is 3, right is 0. Left calculation I think is good. Yes, left calculation, if you see, left calculation is okay. For the last one, 1 1 2 3 4, yes, the left calculation is okay, the right calculation is flaky. So let's see the right calculation. What have we done here? So st2 dot query 0 to max minus 1. We are querying on st2, right? And st2 we have created here of size max. Here we are updating on st1. So this is working. This is I equals to n minus 1, I greater than equal to 0, I minus minus. Yes, right of I equals to st dot query 0 to max minus 1 in the range of 0 to a of I minus 1 with 0, and st2 dot update 0 to max minus 1. We are updating a of I with the value of 0. With the value like update is okay, update will do. So left is working, right is not working. That's weird. QL QR is inclusive. Any issues that you see in the code? Any issues that you see in the code? I don't see any issues, but the right is somehow not returning correctly. So right of I, it is somehow returning everything to be one less. st1 max and st2 max. We have created two segment trees, right? So we have created two segment trees. What if we clear one and we add a statement here, void clear, and it will st n 4 into n. So st equals to vector int 4 into n, 4 into n and 0. We'll clear everything up, 4 into n and 0. So let's take only one of them. Let's take one segment tree out, right? Let's take one segment tree here. So st of max, and here let's update on st and update, and here let's write here st dot clear, right? St dot clear, and again we'll start from fresh. Update 0 a of I 0 st dot update, and 0 max minus 1, and the range is a of I plus 1 to max minus 1, and here it is 0 to a of I minus 1. Number of elements on the right less than the given element. Yes, that should be it. So compile and run. We are still getting one less in the right. Why is that right coming one less? Hi Abhay. Anyone is seeing any issue here with the code? I am actually not able to see any issue here. Anything that I've done wrong, that you find that I've done wrong here, you can let me know. Update, I'm updating in the given, yes, I'm updating in the given position only. Pause. Update index st2 plus plus 1 st2 plus plus 2. Yes, update is okay. Query should also seem okay. Anything that you find wrong here in the range 0 to max minus 1, 0 to a of I minus 1, that is the range we should search for, right? I equals to n minus 1. What was the output for 0? For 1? For 2 also it was 0. For 1 also it is 0. Okay. One is not updated. 0 to max minus 1. Out 0 max minus 1 0 a of I minus 1 slash n. Line 30. Did I do something wrong in line 30? Update index is less than, less than equal to, sorry, my bad. Yes, index is less than equal to mid, then on the left, otherwise on the right. Okay, now I think it will work. Sorry, my bad. We have to remove this, we have to remove this. Any other logging statements that we have? I think we have other logging statements. History.clear. Let's see, let's run this now. No, yes, now we're getting the output, right? 42024. It was because in the segment tree, when we update on the left child, it is less than equal to m, right? So that's why. Yes, now it's successfully solved. So this is the code for this, and this is how you solve it, right? A very silly mistake that I had done here. That's why I don't like the recursive code anyways. Index less than equal to m, then you should go to the left child, right? So the left child range is 0 to mid, minus 0 to mid, and mid plus 1 to 0 to mid, and mid plus 1 to r is, or left to mid plus 1 to r is the right child. So that's why this was the issue. So is it clear with everyone? How is this working? Is this clear with everyone? How is this working? How to solve both the problems? Is both the problems clear with everyone? Both the problems clear with everyone? Yes, no? Good night, Shanak. I think it's clear with you. So thanks for joining. Clear with everyone? Yes, no, yes, no. Write in the chat. Is both the problems clear with everyone? Please write it in the chat once if it is clear. If it is not, then also write which part is not. Okay, I think it's clear with everyone. So thank you guys for joining in, and I'll see you soon.